So let's start.
Yes.
Hi everyone, this is me Anka. Today we have fantastic guest speaker, Professor Arnold Tukker. He is a professor of industrial ecology at the Institute of Environmental Sciences of Leiden University in Netherlands. So thank you very much for your time, Professor. Yeah, how's the trip in Xiamen City?
It was really very nice. We visited the Institute of Urban Ecology and we do a project with them and we have a lot of sightseeing. It was really very nice to learn Xiamen and the province in this way.
Yeah. So what kind of project are you implementing at the moment?
Yeah, here with Xiamen we look at actually a project that we call multi-green. So we look at biodiversity and health planning in a city. And to do that with least environmental impacts. So it's really looking at city level. How do you optimize environmental issues? How do you optimize health? How do you optimize biodiversity? That is the project.
That's the project, okay. So I've seen your profile. You have over 30 years of experience in this industry.
Yeah.
Since 1990 until today. So let me start from very basic and simple questions. Because I would like to know about your insights of urban metabolism and urban ecology.
Yeah.
So my first question is, what is the urban metabolism and urban ecology, and what's the difference between these two concepts?
I'm not even sure if there's a difference. I think what we do, industry ecologists, we look at the society as a material system. We look at how the materials flow through society. Let's say how the demand for cars has an impact on the demand for metals, on the demand for fuel, oil, that kind of things. If you have urban metabolism, you look actually at the urban environment. And there you see the same. You have an urban system. Here in China, you know, we built a lot, or people in China built a lot with concrete. So you're going to look like, how is the urban environment actually influencing all the material flows, directly and indirectly. So if you build a city in a certain way, of course, you need water. You need electricity for, you know, for heating and cooling. You need transport. You need food. Okay, where does it come from? Yeah, the way how you build your city influences these kind of things in a very massive way. If, for instance, you can really build very compact, what we call compact cities, you probably don't need a lot of transport. In Europe, the concept of what we call the 15-minute city is very important.
15-minute city?
Yeah, wow, and that is about that in 15 minutes you can walk to everything that you want to do to have a nice life. So your supermarket is at 15 minutes walking.
Maximum.
Yeah,
maximum.
Something like that. Or your coffee shop is at 15 minutes walking. Your restaurant, your, you know, and you see already, if you have that all concentrated in a small neighborhood, people don't need to travel a lot. Yeah. And if you then on top have, let's say, good public transport, like I think in Xiamen you have good public transport, you can do the longer distances with public transport. If you go to a US city, everybody lives in detached houses, and the suburbs. And you need a car.
Yeah,
you need a car. You cannot live without a car in many places in the US. So that are the kind of things we look at. We look at how the city is structured, how much material we need to build a city. There, China is actually doing a wrong thing. They built a lot in concrete. Concrete is very energy intensive. And okay, that is one of the bad things about China. But it's also how you structure the city, how the life of the people is influenced by the structure of the city. And then, of course, you can see the way how the people behave influences what they have to buy, what kind of impacts what they buy have. And I would say that is industrial metabolism at city level.
I'm going to ask, what is the main factors of having good urban metabolism?
Yeah, I think what we know very well is that people like you and me, we spend our income, and then we see that the income we spend on food, the income we spend on transport, the income we spend on our house, the income we spend on, let's say, electrical equipment, electronic equipment, that are the 4 categories that drive most of the environmental impacts. Yeah, you can imagine everything that has to do with energy creates carbon emissions. The housing system is really important for materials.
Yes.
Everything you do with food is really important for land use and for water use. So we know that these 4 things are very important. Well, then already you see, if you want to reduce that, it becomes important to have, for instance, energy neutral housing. Yeah, housing that here it is quite warm. You want to have natural cooling. You don't want to have air conditioning or whatever, or a very limited use of air conditioning. In my part of the world, it is more about heating, so we insulate our houses quite well, the modern houses. And by that, you can reduce the energy use for heating and cooling. Yeah. You also have to look very carefully how you build your houses. If you do it in China, like with steel and with concrete, you need an enormous amount of carbon to create
the materials.
Yes. Yeah, so that is not good. And they are also heavy materials in large volumes. So there you see again that the US is actually doing something smarter. They, of course, have a lot of natural resources, a lot of wood, but a lot of the houses there are built in wood. Well, there is a natural material that doesn't create a lot of carbon emissions. It's relatively light. So thinking about how you build your houses is very important. It is also about that how many people do you have your house. These other studies that you see, look more at city level, it is so obvious. I mean, I did a study, or I did not do the study, it was actually a Chinese PhD candidate. We looked at, okay, if you really want to reduce the carbon emissions of the material we use for building and construction, yeah, what you basically see in the next 50 years, we can do implement more material efficiency. So we had all kind of improvement options. And then we found out that if you do that, I think we could reduce the amount of carbon emissions related to making all the buildings that we need in the future with probably 70%, 80%. And that was a good result. I mean, it is still not good enough, but you see we can do it. And that is the kind of research that we try to do. Also, when you talk about cars, I mean, I had one PhD quite interesting. Okay, if everybody is going to electric cars, and we do that very quickly, then we throw away the old cars that are still good. But we have to build so many new cars with batteries.
Yeah, with the batteries. The new cars also use a lot of the extra materials.
And then you need extra material. Yeah. And since your energy system hasn't made the change yet, on the short term, you will create more carbon emissions from making all the batteries. Then we save on the short term by driving electrically. On the long term, it works. Yeah. Your energy system is becoming low carbon. The car has a lifetime of, I think, 15 years. So in the 30s, we will see the effects. So it became important to see what is the optimum, let's say, speed of change from traditional cars to electric cars. And what is equally important, what kind of electric car do you have? Is it an SUV, a very big one, with a very big battery? Or is it like a small car, like a mini Toyota or a mini Subaru, something like that? Of course, it's very simple. If we all are happy with relatively small family cars and not SUVs, you need smaller batteries, and the carbon emissions of the battery are going down. You know what's even more important? If we can go to self-driving cars, then the amount of cars that you need will really, you don't own it anymore. Yeah, it will be that maybe a bit like you probably don't have that in China, but like Bolt or Uber or Grab, that are the kind of like,
the application to book the taxi.
you book the taxi or something like that. But now let's assume that we have all self-driving cars. Someone owns a fleet of self-driving cars. I have to go to the airport now. Oh, I just order it, and that car is bringing me there. Well, and then the next day or the next moment you want to go somewhere else and you order. And then all of a sudden you don't need your own car anymore. You can rely on the system of self-driving cars that is used very intensively. And then again, you need less batteries. So all these kind of solutions you have to think of to reduce the environmental impacts related to the material in.
Like we've talked about a lot of materials input, right?
Yeah.
So in terms of material input, in the recent studies highlighted that food, energy, water nexus approach can be used to define urban metabolism studies.
Yeah.
But you've mentioned a lot of other materials like steel,
of
like
course.
a car, and
Yeah.
so which one is more valuable? I mean, like finding out the interconnection, interrelation of food, energy, water, or just focusing on the other materials.
Yeah, it is.
To define the urban metabolism.
It is all important. The problem is that, the food, water, carbon nexus is like, we know that the whole food system at this moment relies a lot on fertilizer, mechanical, equipment and so on. So you have a carbon thing. With food, we also have land use change. Yeah. If we expand, let's say, if we all are going to eat meat like, let's say, the Americans or people from Argentina, the amount of land you use for cows, that is incredible. Once you do that, you have to cut forest. So yeah, that is important. That's why I say the food system is now creating about a quarter of our carbon emissions, but 70% of our water use, and I think equally 70-80% of our land use, something like that. So to look at that, you really have to look at, okay, how can we improve that part of the system? Yeah. And then, of course, you have to look to diets. Can we go down more? Can we be more vegan? We did a very interesting study led also by a Chinese PhD that is now at China Agricultural University and a good colleague of me, Paul Behrens, where we looked at, okay, if everybody in the Western world would actually go to a low meat diet, you would set free so much land if you rewild it. Yeah, so you let actually the natural vegetation come back. The carbon that you store above ground, but also underground, in the roots and so on, that is 3 times the world emissions, 3 times the annual world emissions. So, and that is of course a once-off benefit, but just by changing our diet habits, you really can actually solve already quite a lot of the carbon problem. But then, that doesn't help you if you look at cities. Yeah, I mean, that is a separate thing. It is more like, the whole buildings here, I mean, they don't have an influence on how you and I eat. Yeah, that is more or less separate. The buildings and how you structure your city do have a lot of implications for how we do a transport. Yeah, if you all have, let's say, you work there, you have basically houses there, it's all maybe small family houses, very spread out. You can imagine already, it's very difficult to have good public transport because it's not dense enough. Yeah. Here we have in China a lot of high-rise buildings, a lot of people, so one metro station, it can be okay. Yeah. And you can walk maybe 500 meters to your metro station. That's all okay. So the way how you do your spatial planning has implications for transport needs. And then we get, that's another big driver of carbon and material emissions. The way how you build your houses, again, drives a lot of carbon emissions and material requirements. The way how you build your houses has massive implications for the energy you use for heating and cooling. So maybe it's almost that you see 2 things, that you have things in urban planning that have quite a lot of influence in the behavior of people. Yeah, I mean, you have to go to your work and all this kind of things. You have to go shopping. And you can imagine, if the only nice place to go out with your friends is Xiamen City, okay, we know we have to take the metro for half an hour or 40 minutes, and only then I can have, let's say, a good meal with you. If you have the 15-minute city, we find everything around it. We can walk to it. You don't have to take the metro. you're happy in your own neighborhood. Yeah.
Yeah.
So these kind of things you really have to think about. Yeah.
Yeah. So we've talked about mostly input of
Yeah.
to the city.
Yeah.
So in terms of urban metabolism perspective, output also very important.
Yeah.
And then between input and output, we also think about circular economy and so on. And can you tell me about output, right? Because you mentioned electric cars could be valuable for long term.
Yeah.
But what would be the waste of batteries?
Yeah. That's again an important part. Actually, my inaugural speech was on the circular economy. And what you see is that we expand still the economy. Yeah. I don't know if you're familiar with Lego bricks.
I know. Yes.
Yeah, I hope
my son's favorite one.
Good. Okay. The example I always give: if your son has a nice box of Lego bricks and he can build 3 houses of it, great. Lego is the most circular material you can imagine because you can take it down again, you have your bricks again, and you can build new houses.
And then it can be moved.
Yeah.
It can be built anywhere you
want. But if I have a box from which I can build 3 houses of a certain size, I never can build more. Yeah. So the problem at this moment with our economy is many people don't have good houses yet. Many people don't have good transport yet. Car batteries, they are, in my country, maybe 10% of the cars are electric. So for the new batteries, for the new houses, we need new material. That is inevitable.
New natural resources.
Yeah, it's inevitable because we don't have them yet in our system.
Exactly.
So what I always say, most of the materials that we need in our system, we still have to mine it.
Yes.
Yeah, because we expand. We did the analysis. I think at this moment, of the inputs into the economy, half of it we can, in principle, reuse. The other half is food and energy materials. Okay, energy materials you burn, food you eat, you cannot directly recycle. But the other half, in principle, you can reuse it. You know what the problem is? 80% of that other half, 40% of the material use, goes into long-term use. Buildings, cars, and so on. And only the 20% that is not going to long-term use, we can, or that goes back, we can recycle at the moment. So what we have to do is make sure that everything we put on the market now, that is your outputs, that we can recycle it easily in the future, or reuse, or the components.
So that is what we have to think about from the starting point.
Totally.
From the starting point, think about that should be recycled.
Exactly.
Yeah.
So I see a number of examples that sometimes people now build houses with very well-defined, prefabricated components. And if you want to say, like Lego, almost. So maybe in 50 years you think, okay, this house is not good anymore. Well, if you then can have the steel bars back, the facade back, and you can reuse it somewhere else, that is great. What do we do now in the Netherlands? We have, let's say, old houses, old office space. We crush it, you know?
Just crush it.
Just crush it. No recycling. You know what we do with the recyclate? It is, let's say, granulate. We put it under a new road. That is not recycling, that is downcycling. So we really have to think, and the same applies for car batteries, for instance. How does this future system, if, for instance, what is well known with car batteries, they need to be charged every day and go up and down. I think if you, the maximum charging capacity is up to 80% or 70%, actually it's not good enough for a car anymore. But if you have solar panels on your roof and you want to have a static battery that is, you know, you can actually use an old car battery. For storage.
For storage.
Because it's not so critical. Yeah, it's not like I give gas, I need a lot of electricity now. It's real. So an old car battery that is not good enough for a car anymore, you can reuse maybe a static
solar panel.
Yeah, and you know, then with the solar panel it stores the energy, let's say for the night. Yeah, something like that.
As a
But
energy
I'm
storage.
not a battery specialist. But
I know.
I've been also told that if you design your batteries in a smart way, and you see that the loading capacity goes gradually down from 100 to, there are ways to actually upgrade the battery again with relatively simple means, But then the designer of the battery really has to think about it.
Yeah.
How to do that? Can you maybe, I don't know, new electrolytes or whatever, relatively simple things, and you have almost a refurbished battery. That are things we have to think about. And we have to think about if you really cannot use it anymore. At this moment, if you want to separate all the metals in the battery, it has to go to a high temperature process. You have to separate it, very difficult. Maybe there are better recycling options. I don't know. Yeah, but we have to think about it from the start.
Starting point.
And I repeat myself, everything that you build new, make sure that you do that with the lowest carbon emissions as possible. So make sure that if you, the minimum amount of cement, the minimum amount of steel, that kind of things, maybe use natural stone, I don't know, maybe use wood, these kind of things. Build the houses in such a way that they are low energy, that they have natural ventilation, all these kind of things. I mean, that are all important things. And if you can integrate things like urban farming and a number of these other kind of things, yeah, I think that is the way to go.
We use different variety of approaches like life cycle assessment, material flow analysis, water energy footprint, right? And also like water system metabolism and so on. So all of these approaches are, crossed on one point, which is carbon emission. What's the carbon emission of the process? Like, for example, in order to produce food, or maybe in order to produce energy, they also use water. In order to produce water, we also use energy, right? So, and there are a lot of databases were developed, like Xiamen Pro, akin, Gabi, and so on. From your perspective, based on your experience, how reliable are these databases?
Yeah, that's a difficult question, because the problem with life cycle assessment databases is that I think many of the data, individual factories don't want to have the data in, because you can see exactly how they produce. So what has been done a lot in the 1990s and the 2000s is that, for instance, for plastic production in Europe, you do an inventory over all the factories. You make an agreement with the Association of Plastic Producers. You get confidentially these data, and then you aggregate it to an average for Europe. That is what's been done. And that is a lot of work. That is a lot of hard work. Actually, I was not much involved in that, but the people from akin, that is exactly what they did. There were all kind of people doing projects. They gave the data to akin, and akin made a consistent database. The problem is that at some point these databases get old. And then updating it is difficult. I mean, what they do is, of course, for energy systems, that is relatively straightforward, because I mean, the carbon emissions for, let's say, power plants, they are reported by many countries. You know how much power is generated. So there you can easily update, let's say, an average kilowatt hour in the Netherlands, that is so many carbon emissions, and for France you can do that. But for other, it is more complicated. So what the LCA people usually do, they look at their material system. So it's often a combination of material flow analysis and LCA. And then for the really important process, you try to get primary data.
My next question is for young researchers who is focusing on urban metabolism, right? So based on your experience, what is the main biggest gap in urban metabolism studies as of today?
I think there's still a lot to do. I think
there's still a lot of that.
I think, in a way, I was surprised that this one PhD that really looked at the material use of, let's say, the future infrastructure. In a way, that wasn't done yet. There had been a study led by the International Resource Panel, but they had focused on China and the US, no global. So then between the supervisors and the PhD, we thought, okay, it's really good if you use another database of another PhD of us that looked at the future amount of square meters of buildings, that was there. And then we said, if we can make an estimate of how we build these buildings, how much in wood, how much in cement, how much and so on. If you make an estimate how we produce steel in the future, that was all his work. And I think it's maybe too difficult to say in general, like that and that are the big gaps. I think the field is quite mature. What you have to do is really look at the literature, what is out there. I will explain a little bit where there are still gaps. But it's really looking with your supervisor and your, let's say, your group manager, like, okay, what are the things where our group already has a presence in school, and what are the next steps that really make a difference? I think when I look back, that is what we probably at CML, with a number of people, it was not only me, it was Paul Behrens, it were a few other people. They were really keen and really very smart, maybe Esther van der Voet as well. Oh, we see now, this is what we know, and what is typically the strength of our group. And if we add that database and that calculation, then we have really something interesting. Yeah. So the example I indicated for, a lot of people had done studies on diet change and the direct reduction of carbon emissions in a year. And Paul and Zhongxiao came up with the idea, but hey, wait a minute, we also have less land use. What is the carbon benefit of less land use? That wasn't done yet in this way, And so they did that. They contacted people who were very good in underground carbon sequestration. They had a model for it, and we put it all together. And then all of a sudden, we had a study that won a very famous prize. Big lines. I think the whole story that I repeated already a few times. How do you structure a city that people are incentivized or almost automatically live a low carbon life? That is, I think, a key thing. One of my good colleagues, Edgar Hedwig, did 20 years ago a very nice study. And he looked at Vienna, where you had a quarter where you could not have a car. So, of course, I mean, all these people, when he started to calculate the environmental impact of the life of the people, looked very good initially, because compared to a village in the countryside, that was his control group. They drove less, all these kind of things. They lived in smaller houses, used less, looked all great. Until he looked, where do these people go on holiday? What do you think? The people who lived in a village in a very nice environment, they were okay staying at home almost. Or they made hikes in the mountains. What did the people in the city do?
Cities, yeah.
They flew to Turkey to have holidays at the sea.
A lot of flights.
And then all of a sudden he noted that, it didn't matter anymore, because, the flights were, actually soaking up all the carbon benefits that he calculated for living in smaller houses and having lower commuting. So that are the kind of things that I think are really interesting. So it is on the one hand a very technical thing. I mean, we can design technically probably a building that is low carbon, low energy use, and so on. But to look how that influences the behavior of people, interesting. I think the methodologies, they are already there. You can look at how a city is built, how the people behave, where the materials, the food they buy comes from, do a nice LCA of your food intake, and we get a picture of that. That is okay, we can make these databases. I think what I already said, what is really interesting is the combination of our quantitative assessment of environmental impact, the expertise that urban planners have, and ideas about how you can create a context, an urban context, by which without thinking, people like you and me behave more sustainably. And that are things like, okay, the ideal is from the 15-minute city that we don't need a lot of commuting anymore, that we can live quite happily in our own neighborhood, which may imply that you don't take a lot of package holidays anymore because your neighborhood is so nice, that kind of things. But we need quantitative assessments of that. We need to look like how was Paris working, let's say 20 years ago, and with all the policies they have now to really create this 15-minute city, is it indeed better for the environment? That is really interesting. You can.
But we have to think about our nutrition,
Yeah.
like food diet, right? But for example, I'm Mongolian,
Yeah,
and our climate is harsh.
yeah, yeah,
It reaches -40 in countryside, and the
Yeah,
city maybe
yeah.
it reaches minimum is -35 or 30.
yeah, yeah,
But in this cold situation, cold weather, we have to have a meat,
yeah, yeah, yeah,
beef
yeah,
and
yeah.
lamb. And then maybe if compared with the South Asian countries,
Yeah.
the Mongolian people's meat consumption is quite
Yeah.
higher to keep to survive in this cold weather
Yeah.
and climate.
I think we would eat meat once or twice a day. Yeah, we get so used to eating meat every day that now we have a very concentrated animal husbandry system. It's almost an industrial system. So most of our pigs, most of our chicken, they don't see the daylight anymore. They're basically in buildings. They're fed with feed that comes from far away, from Brazil and so on. And that creates the problems. So I think you're a very not a densely populated country. I mean, you have probably indeed only places where you can have sheep and goats and that kind of thing. So
Yeah, and
okay,
only 3 million populations meat consumption isn't that high if compared with other big countries, right?
So I think maybe you have to look at these things as well. Yeah.
Yeah, yes. But another very interesting point is about NDC, National Determined Contribution.
Yeah.
We need to look at things from global perspective or national perspective.
But that is a well-known story. I mean, you have the whole story about, food miles, eat food that comes from close. Okay. Then it appears that the climate in New Zealand is so good for apples that actually the UK should import the apples. Ship is not a very big impact, shipping,
Yeah.
So import your apples, please. Tomatoes, same thing. We have them in greenhouse gases. We heat these greenhouse gases with gas. No, it's obvious. If you want to have tomatoes, bring them from Spain. Yeah, that kind of thing. So there is indeed a trade-off, and it is literally about optimizing at which scale. Is it within your country? Is it within a continent? Of course, you have things like food security. One of the reasons that my country is now so incredibly good with what time is it, by the way? Because about 12.
Yeah, we are nearly finishing.
Yeah,
what time is it?
Oh, that's it. Yeah, no, that's then I have to
You're
almost go. You're also. Yeah. I already checked out, so we can just walk away. That is good. Yeah. Okay, we close off now.
Yeah, we close off. Just 5 minutes.
Yeah.
Oh, what was it?
Where was it? Where was I?
We were talking about
the reason why the Netherlands is such a big, it's incredible. We are a very small country. We have about 80 million people at the moment, or 17. We are, after the US, the biggest food exporter in the world. Ridiculous. How is it possible we are like this? That is because we have this very intensive meat production for which we import a lot of fodder. The animals eat it, and we export, all kind of meat and whatever. Where did it come from? Before the Second World War, and in the Second World War, we actually had import country. We had food shortage. Very traumatic experience. At some point, the military situation was such that the west of the Netherlands was cut off from the rest of the continent because, the Canadians and the English already had. We had famine. People died. I mean, okay, maybe here in this part of the world you're used to it. For us, it was a shock. We hadn't had that for maybe 50 years or 100 years. So then after the war, there was really a program. Let's make sure that we can produce as much food as possible. So we had programs to have the milk production per cow going up and that and that. The EU did the same. Yeah. So, and it was a success. We really produce in the EU now all the food that we can make ourselves. We do it ourselves. Certain things like kiwis and whatever we have to fly in and so on. Yeah. And so there is a trade-off between being, let's say, independent and maybe we actually produce a number of things in Europe that you better can produce abroad. That's all possible. Yeah.
Wow. I really want to continue this interview, but time is limited.
Exactly.
It's really interesting to listen some interesting stories and intriguing information regarding urban metabolism from experts.
Yeah.
You know, yeah. I'm wordless, to be honest. It was really helpful. I hope
Okay.
this video is very informative for young researchers
Yeah,
as
I
well
hope so.
as citizens
Yeah.
all around the
Yeah.
world. Yeah.
Okay.
Thank you very
so
much.
much.
Yeah.
Thank you. Bye
Have
bye.
a safe trip.